In this unit, we will introduce file reading, writing, and operations. This unit mainly consists of three parts: file reading and writing, data table operations, and large file operations. The data table here refers to the data file that can be run in memory, and the large file refers to the data that cannot fit into the memory. Section 1. File reading and writing. This section includes text file reading and writing, Excel file reading and writing, and common operations on files and directories. Let's start with text file reading and writing. Read and write structured text. The format of structured text is relatively regular, that is, there is one piece of data in each line, and the columns are separated by separators. For example, the file orders nt.txt stores the order information, and the columns are separated by the tab. The business meanings of every column sequentially are order ID, customer number, sales ID, order amount, and order date. The task is to sort the orders in ascending order alphabetically by customer number, and then sort the orders with same customer number in descending order by order amount, and finally save it to a new file in the original format. SPL can use the function import or export to read and write the structured text. A1, read in structured text file. A3, write out structured text file. A2, the function sort is to sort. _2 and _4 represent the second and fourth columns respectively. By default, they are sorted in ascending direction, and the negative sign represents the descending direction. SPL can also process the text file with column name. For example, the first line of orders.txt is the column name. Likewise, sort this file and write the result to a new file together with column name. The import or export with the option at T means the text file is read and written together with column name. A2 is to sort by column names rather than sequence number. The default separator of the function import or export is tab, and the option at C means that the comma is used as the separator, which is usually used in CSV files. If other special separators are encountered, SPL can also handle. For example, the file orders _semi.txt uses double vertical bar as the separator. The code is like this. The default function of the function export is to write the data to a new file, or to overwrite the file with the same name, but sometimes we need to append new data with the same structure to the original file. In this case, we can use the option at A. The format of some text files is not regular, and it cannot directly perform the structured calculation. Such files, however, can be read as a sequence of strings. The formats of such semi-structured data are numerous. Let's take multi-line records as an example to illustrate the general method of reading and writing the string sequence in SPL. The first two lines of every three lines in the file 3lines.txt correspond to one record, and the third line is useless. Part of the data is shown in the figure. The task is to remove the useless line from the file and write the result to a new file. The function read is to read the file and return a string. Adding at n means returning a sequence of strings, with each line being a member. The function write is to write the string or sequence to a file. The step in A2 means taking the first member and the second member for every three members of sequence A1. In addition to text files, Excel files are also commonly used. The structured Excel table is relatively regular, and SPL reads and writes it with the XLS import and XLS export functions. For example, the file orders nt.xlsx stores some order information. Now we want to arrange the records in the second column and the fourth column in ascending order and descending order respectively, and then save the result to a new Excel file. The functions XLS import and XLS export can read and write Excel files. By default, the first sheet is to be read and written. Adding a sheet name or sheet number in the parameter allows you to read and write the specified sheet. SPL can also process the structured table with column name in a similar way to process text files. Adding the option at T means reading and writing Excel files together with column name. Sometimes the first few rows of the table are useless and need to be skipped. For example, the first three rows in the figure are useless, skip them and read data starting from the fourth row. Pay attention to the symbols in front of parameter 4 and don't write them incorrectly. When appending new data with the same structure to an Excel file, we can also use the at A option. If the appearance attribute is set for the last non-blank row of the original table, the appended data will inherit the style of this row. For example, if the number style of column D and the date style of column E in the original table are set as shown in the figure, then the appended data will inherit the two styles. If the style attribute has been set for the first blank row after the last non-blank row of original table, the appended data will inherit the style attribute of this blank row. Using this feature, we can achieve the data output from scratch in the specified format. For example, first create a blank Excel and set the style of columns D and E in row 2, and then use @A to append data to the blank table. As a result, the appended data will inherit the style set for the blank row. Some Excel tables are not regular in format and do not have clear column attributes. In this case, they can be processed as a two-dimensional string sequence. For example, the key value data in the figure. Now we want to split the data into two columns by key and value, and sort them by key and value, and finally write them to a new Excel. The result is like this. XLS import with the option @W means reading Excel data as a two-dimensional sequence, that is, the whole is a two-layer sequence, each row is both a member of the outer layer sequence and a sequence, each cell in the row is a member of the inner layer sequence. Once the data is read as a sequence, it is easy to handle. First remove the blank cells, then use equals to split the sequence into key and value, and finally sort by key and value. The result of A4 is also a two-layer sequence. Similarly, using XLS export @W can write a second layer sequence to Excel. What we discussed above are reading and writing Excel in units of tables or sequences. Sometimes we also read and write Excel in units of cells. For example, this table has the editor and edit date in row 1. Now we want to copy the editor and edit date to the corresponding position on row 7. A2, the XLS open function opens the Excel file as an object. A3, read the cell A1 and assign the variable str. By default, it is to read from the first sheet. If you want to read the cell A1 in the specified sheet, you can add the sheet number or sheet name in the parameter. B3, write contents of str to cell A7. The function XLSCell is used to read values from or write values to the Excel object. When there is no semicolon in the parameter after it, it means reading, such as A3. When there is semicolon in the parameter after it, it means writing, such as B3. Similarly, A4 means reading cell E1 from the Excel object, and B4 means writing str to cell E7 of the Excel object. XLSWrite means saving the Excel object to an Excel file. In this example, A1 to E1 that need to be read are consecutive cells, and A7 to E7 that need to be written are also consecutive cells. For the reading and writing of such consecutive cells, SPL can implement with a more simplified code. A3, read consecutive cells in sequence format. A4, write the sequence to consecutive cells, and each member of the sequence corresponds to one cell. You can either use a sequence to write data to consecutive cells or use a string separated by \T or \R, where \T means horizontal separation and \R means vertical separation. Using Excel objects can not only read and write cells but also process multiple sheets. For example, a certain Excel uses multiple sheets to store the order tables. Each sheet has the same format, but the number and name are not the same. Now we want to sort these orders into a new Excel to make each sheet store 1 year's data. A1, open the source Excel file as an object. A2, traverse each sheet, read the order of each sheet, and concatenate all the orders. A1.stName means taking out all sheet names from the Excel object A1. A3, group the orders by year. A4, open the target Excel file as an object. @W means write mode, and a new file will be created if the file does not exist. A5, traverse each group of orders of A3 and write them to the new sheet of A4 in turn. A6, the Excel object opened in @W mode must be closed with the function XLSClose. Files and directories. Parse file name. The function file name can parse out different parts of the file name. File name without option means to output file name with extension. File name with the option @E means to output extension. File name with the option @End means to output file name without extension. File name with the option @D means to output path. If you already know every part of the file name, you can use the concat function to piece together the full path. Traverse files. Sometimes we need to operate on a batch of files. For example, there are a batch of Excel files under a certain directory, and the first sheet of these files stores the order data with the same structure. Now we want to concatenate these orders into a new Excel file. Use the directory function to return all file names whose extension is xlsx in the directory. @p means returning the full path. Then loop through the file names to read Excel and concatenate the data. The function directory has more functions, such as using the @s option to search for subdirectories recursively, using the @d option to list subdirectories, using the @r option to delete directories, and using the @m option to create directories. In the previous example, we used the full path to access the data file. If the main path in the system directory is configured, it can be used as the root directory. In this case, we can use the relative path to access the data file. If the main path is not configured, and a direct relative path is used, the actual main path is the directory where sproc is started. When sproc is started directly, or started via shortcut, the directory is sproc installation directory /bin. When double-clicking the dfx file to start sproc indirectly, the directory is the directory where the dfx file is located. In addition to the main path, sproc has other important system directories. Temp is the directory where the calculation engine stores temporary files. If it is not set, the operating system temporary directory will be used by default. Searching path is the root directory of the script file, including the main path. Multiple directories can be set, and the directories are separated by semicolon. Section 2. Data table operations. This section includes operations on data tables, such as filtering, aggregation, intercolumn, grouping, top-n, distinct and association. Filtering. A filtering operation is to select records that meet the specified condition from a data table. For example, filter out scores of students in class 10 from the student scores table students_scores.txt. The first row of the file contains column names, and detailed data begins from the second row, as shown in the figure. The select function means selecting members that meet the condition. First use the t function to open the text file, and then use the select function to filter. Aggregation. An aggregate operation is to summarize data in a table. For example, calculate the average Chinese score, the highest math score, and the total English score on all students in the student scores table. A1. Read data from the file. The t function will automatically choose the appropriate separator according to the file extension. A2. Calculate the average Chinese score. A3. Calculate the highest math score. A4. Calculate the total English score. Intercolumn calculations. The intercolumn calculation performs a specific operation requiring values of multiple columns. For example, calculate each student's total score based on the student scores table. A1. Read data from the file. The t function will automatically choose the appropriate separator according to the file extension. A2. Add a column named total_score to A1, whose values are sums of values in English, Chinese, and math columns. After execution, A2's result shows that the total_score column is added to the table. Another example, get the evaluation result for each student's Chinese score based on the student scores table. A1. Read data from the file. The t function will automatically choose the appropriate separator according to the file extension. A2. Add a column named Chinese_evaluation to A1, whose values are excellent, good, pass and fail when the Chinese score is above 90, above 80, above 60 and below 60 respectively. Sorting. A sorting operation is to sort data in a table in ascending or descending order. For example, arrange records in student scores table by class number in ascending order. Use the sort function to sort class. The sort function can also have multiple expressions. For example, A3 means sorting by class number in ascending order and then by math score in descending order. The negative sign means sorting in descending order. Getting top n. A top n operation is to get the first n records or values meeting a specified condition from a data table. Many times we only care about the top n, in which case there is no need to do a full sorting. For example, get score records of the 3 students whose English scores rank in top 3. A1.top, -3, English, returns the top 3 English scores, while A1.top, -3, English, returns the records for the top 3 English scores. Grouping and aggregation. For example, query the lowest English score, the highest Chinese score, and the total math score in each class. Use the groups function to perform grouping and aggregation operation. Group A1 by class and then calculate the lowest English score, the highest Chinese score, and the total math score in each class. Post-grouping filtering. Find classes where the average English score is below 70. A1, read data from the file. The T function will automatically choose the appropriate separator according to the file extension. A2, group A1 by class, calculate the average English score in each class, and name the new column average_en. A3, select from A2 records where the average English score is below 70. Intragroup top n. This operation is to group data in a table and then get top n records or values from each group. For example, find score records of the 3 students whose English scores rank in the lowest 3 from each class. Group A1 by class, sort each class by English score in ascending order, and get the 3 lowest English scores from each class. Distinct. Get all class numbers. The ID function will return the distinct values in the sequence to implement distinct operation. There is also a distinct related operation, count distinct. For example, calculate the total class numbers. The iCount function will count the number of distinct members in the sequence. We can also implement intragroup count distinct operation. For example, count dates having sales records for each product based on this sales table sales.txt. Group A1 by product number PID, and count unique dates in each group and name the new column days. Foreign key association. For 2 data tables, certain fields in Table A associate with Table B's primary key, then Table B is called Table A's foreign key table and this association is called foreign key association. Example, the order information and the product information are stored in 2 Excel files respectively. Now we want to calculate the sales amount of each order. The data structures of the 2 files are shown in the figure. There are 2 methods to handle such single foreign key association. Method 1. Use the switch function to associate A1's product ID with A2's ID. ID can be omitted if it is the primary key. At this time, the original product ID column values are converted into the corresponding product records. Then add a new column named amount to A3, whose values are results of sales quantity multiplied by product price. The expression product ID.price means the value of price field in the record pointed by product ID field. Method 2. Use the join function to associate A1's product ID with A2's ID. ID can be omitted if it is the primary key, and introduce name and price fields from A2. The switch function cannot be used for multi-foreign key association. Instead, the join function should be used to do that. Suppose the prices are different for different types of packaging, and we add a packing field to both the product table and the orders table. Now the product table has a composite primary key of ID field and packing field. In this case, the only method to calculate the sales amount is to use the join function. Use the a.join function to associate A1's product ID and packing fields with A2's primary key and introduce name and price fields from A2. Primary key association. For Table A and Table B associated through their primary keys, they are called homodimension tables. The homodimension tables have a one-to-one relationship and logically, can be treated as a single table. Homodimension tables are associated via primary keys and their records have a unique correspondence. For example, there are employee information table, employee.xlsx, and salary table, salary.xlsx. Both use EID as the primary key. Now we want to query the basic employee information and the corresponding salary information. Use the join function to associate A1 with A2 through EID, and name A1 AMP and A2 salary. Note that the join function used here is not the same as a .join in foreign key association. Then select EID, ID card, name, sex, phone, and depart from A3's AMP and wages and bonus from A3's salary to create a new table sequence. The primary key association may happen between the primary table and the subtable. For Table A and Table B, when the former's primary key associates with part of the latter's primary key, then Table A is called the primary table and Table B is the subtable. The primary table and the subtable has a one-to-many relationship. For example, here is an employee family table, family.xlsx, where the primary key is made up of EID field and FID field. Now we want to query the information of employee who has at least one family member who is above 70. A1, read employee information. A2, read employee family information and get records of members whose ages are above 70. A3, use the join function to perform a filtering join on A1 and A2 through EID by deleting non-matching records and name A1 employee and A2 family. A4, get employee column from A3 to concatenate its records as a table sequence. Section 3. Large file operations. The so-called big data refers to the data that cannot be loaded in the memory. It is generally stored on the hard disk in the form of file or in the database. This section does not involve the database, but only the big data in the file. Excel files are generally not too large because there is a limit on the maximum number of rows. Large files are usually in the text or CSV format mentioned above. According to the memory of modern computers, it takes tens of millions or even hundreds of millions of lines of data to be big, and the file size will be several gigabytes or dozens of gigabytes or more. To implement large file operations, it needs to understand an important concept, cursor. We were more familiar with the database cursor. Using cursor in the database can return part of the data each time without having to read all the data into memory at the same time. A cursor is like a pointer. When reading data, it extracts part of the records from the result set each time by moving pointer's position. Similar to database cursor, file cursor is also needed when reading data from a large file, and it has the following characteristics. 1. It is only used to get data, not to modify result set. 2. When reading data, it can only move forward and can only traverse data once. With a cursor object, we can attach large file calculation steps to the cursor object in turn. When performing final calculation, we can fetch records one by one and calculate according to the attached steps. SPL provides all-round cursor objects and operations. This section will take structured text files as an example to illustrate the methods for implementing operations on large files, such as filtering, aggregation, adding computed column, sorting, grouping aggregation, top N, and parallel computing. Filtering. Let's still take the student scores table as an example. Assuming the amount of data is large and cannot be loaded in memory, we want to get scores of students in class 10 and write the results to a new file. The cursor function means opening the file and creating a cursor, and a T means reading the first row as column headers. Select is also a cursor, but it is a deferred cursor. A deferred cursor will not be executed immediately, but just remembers that there is a selection action to be done on the cursor, and the action will not be executed until the next step of export. The export function can write the cursor directly to a file. Aggregation. Calculate the average Chinese score, the highest math score, and the total English score on all students in the student scores table. Unlike in memory calculations, there are no aggregate functions, such as sum, average, and count directly on a cursor. Because the cursor traversal is very slow, we should calculate as many results as possible during the traversal. If we provide functions such as sum and count, we need to traverse the cursor once for sum and once again for count. The performance will be very poor. It is also troublesome to create a new cursor in the code, so SPL does not provide it at all. The total function is used to achieve multiple aggregates on a cursor within one traversal. This is an immediate calculation. Inter-column calculations. Calculate each student's total score based on the student scores table. Use the derive function to add a new column named total_score to A1, whose values are sums of values in English, Chinese, and math columns. Similar to the select on a cursor, derive is also a deferred cursor. The fetch function means fetching the first 100 rows of data from A2's cursor, and, until now, the derive action attached to the cursor begins to be executed. Sorting. For sorting large files, due to space constraints, it is not possible to read all data into memory for sorting. The general steps to solve this problem are as follows: read in some data, sort in memory and write out the result, then read the next part, sort and write, and so on. Finally, a batch of ordered intermediate results will be obtained, and then the merging algorithm will be used to concatenate these intermediate results. SPL provides the sortX function to perform big data sorting. This function implements all the above series of processes. Because the sorting result is still big data, sortX will also return a cursor, but it is not a deferred cursor. SortX will calculate immediately, and the returned cursor is based on the intermediate results described above. For example, arrange records in student scores table by class number in ascending order and by total score in descending order. As a reminder, sortX may be slow and need to wait for some time after running. It also takes up some hard disk space, used to store intermediate results. sproc will use the operating system temporary directory by default, or you can set the temporary directory yourself in the options. Grouping aggregation. There are two situations for grouping and aggregating large files. One is that the grouped result set is not large and all grouping results can fit into the memory, which is called small grouping. The other is that the grouped result set is so large that all grouping results cannot fit into the memory, which is called big grouping. For small grouping, just like in memory calculations, we use the groups function, which will be executed immediately and return grouping results. For big grouping, since a large result set cannot fit into the memory, we need to handle the grouping aggregation of a big file in batches, during which the result of processing each batch of records is stored in a temporary file and then all temporary results are summarized. SPL provides the groupX function to perform big grouping, which will also be executed immediately, but it returns a cursor and we need to use fetch to view results. Getting top N. Get score records of the 3 students whose English scores rank in top 3. Similar to aggregate functions, there isn't a top function in cursor functions. The top operation need to be performed within the cursor total function, and this is an immediate calculation. Intragroup top N. Get score records of the 3 students whose English scores rank in the lowest 3 from each class. When the grouped result set is not large, use the groups function. This is an immediate calculation, and it returns the grouping results. When the result set is large, use the groupX function. This is also an immediate calculation, but it returns a cursor. When using the top function, pay attention to distinguish whether the parameter separator is comma or semicolon. Distinct. Get all unique class numbers. When the grouped result set is not large, use the groups function. This is an immediate calculation, and it returns the grouping results. When the result set is large, use the groupX function. This is also an immediate calculation, but it returns a cursor. Count distinct. Calculate the total class numbers. Read the data as a cursor and use iCount to traverse and count in the total function. Intragroup count distinct. Count dates having sales records for each product based on the sales table sales.txt. Read data from the file as a cursor. At T option reads the first row as column headers. Group A1 by product number PID, and count unique dates in each group and name the new column days. These are immediate calculations. When the grouped result set is large, use groupX function to perform an immediate calculation and return a cursor. Foreign key association. For 2 data tables, certain fields in table A associate with table B's primary key, then table B is called table A's foreign key table and this association is called foreign key association. Example, the order information and the product information are stored in 2 Excel files respectively. Now we want to calculate the sales amount of each order. The data structures of the 2 files are shown in the figure. There are 2 methods to handle such single foreign key association. Method 1. Use the switch function to associate A1's product ID with A2's ID. ID can be omitted if it is the primary key. At this time, the original product ID column values are converted into the corresponding product records. The switch function on the cursor is a delayed calculation. Then add a new column named amount to A3, whose values are results of sales quantity multiplied by product price. The expression product ID.price means the value of price column in the record pointed by product ID column. Derive is also a deferred cursor and will not be executed immediately. The fetch function will fetch the first 100 rows from the cursor, and until now, the operations attached to the cursor begin to be executed. Method 2. Use the a.join function to associate a1's product ID with a2's ID. ID can be omitted if it is the primary key, and introduce name and price fields from a2. Similarly, join is also a deferred cursor, and it needs to use the fetch function to view data. The switch function cannot be used for multi-foreign key association. Instead, the join function should be used to do that. Suppose the prices are different for different types of packaging, and we add a packing field to both the product table and the orders table. Now the product table has a composite primary key of ID field and packing field. In this case, the only method to calculate the sales amount is to use the join function. Use the a.join function to associate a1's product ID and packing fields with a2's primary key and introduce name and price fields from a2. Both join and derive are delayed calculations. Primary key association. For table A and table B associated through their primary keys, they are called homodimension tables. The homodimension tables have a one-to-one relationship and logically can be treated as a single table. Homodimension tables are associated via primary keys and their records have a unique correspondence. For example, there are employee information table, employee.xlsx, and salary table, salary.xlsx. Both use EID as the primary key. Now we want to query the basic employee information and the corresponding salary information. In Big Data, use the joinX function to associate A1 with A2 through EID, and name A1 AMP and A2 salary. It should be noted that joinX requires the association keys to be in order to work, so it needs to use the sortX to perform a sorting operation before associating. Of course, if the original data is already ordered by EID, just skip the sorting operation. Then use the new function to select EID, ID card, name, sex, phone, and depart from A3's AMP and wages and bonus from A3's salary to create a new table sequence. JoinX and new are both deferred cursors and their operations are all delayed calculations. The primary key association may happen between the primary table and the subtable. For table A and table B, when the former's primary key associates with part of the latter's primary key, then table A is called the primary table and table B is the subtable. The primary table and the subtable has a one-to-many relationship. For example, here is an employee family table, family.xlsx, where the primary key is made up of EID field and FID field. Now we want to query the information of employee who has at least one family member who is above 70. Use the joinX function to perform a filtering join on A1 and A2 through EID by deleting non-matching records and name A1 employee and A2 family. Likewise, it should be noted that the association keys must be in order. Then, get employee column from A3 to concatenate its records as a table sequence. Conjunction operation is a delayed calculation. The parallel processing handles one computing task using multiple threads. It makes the most of the multi-core CPU to increase computing performance, which is particularly effective in processing a big file. Batch processing handles a big file batch by batch and then union the results together. Parallel processing works in a similar way. It divides a big file into multiple segments, assigns each segment to a thread, which handles its part using the way of processing a big file, and finally, union the results returned from every thread. For example, the big file user_info_egg.csv records user login information. We need to count the number of user logins in each province. Here we handle the task through 4 parallel threads. Use the cursor function to create a cursor. The @m option means parallel processing. Parameter 4 means there are 4 parallel threads. The @t option means reading the first row as column headers, and @c means using comma as the separator. In SPL, multiple options can be used in combination, regardless of order. Another example, the big file students_scores.csv stores student scores. The task is to get students whose Chinese scores are above 90 and whose total scores rank in top 5 using 8 parallel threads. Create a cursor. At M option means parallel processing, parameter 8 means there are 8 parallel threads. Get the students whose Chinese scores are above 90. Attach derive operation to calculate total score and add a new column named total_score. Group records by class and get students whose total scores rank in top 5 in each class. Finally, export result to a new file. It can be seen from these two examples that it's easy to implement parallel processing in SPL. You just need to add an option for retrieving data with cursor and use a parameter to define the number of threads. That's convenient.